this is a fairly complex algorithm, and it will not be possible to get into the details in this webinar. For those advanced users, a quick look at the source code of Minstrel. So the normal Minstrel is used for 11A, B and G, while Minstrel HT, that is high throughput Minstrel, is used for 11N and 11AC. The file minstrelht.c, which we have just selected, consists of important functions like update rate, update packet counter, find rate, update stats, etc. It's a very complex algorithm with more than 20 functions, and it is the current rate adaptation algorithm used by the latest Linux releases. So this is just an example where we have compared our generic rate adaptation algorithm for a managed scenario using 802.11b, and you can see how much superior Minstrel is by looking at the increased throughput that the Minstrel rate adaptation algorithm provides. Now let us look at the 256 QAM modulation used in 11AC. QAM is a form of modulation that combines phase modulation and amplitude modulation. The QAM scheme represents bits as points in a quadrant grid known as a constellation map. Depending on the modulation scheme, more bits can be represented at a given constellation point. Consequently, a higher signal quality must be present to distinguish between the constellation points when using high modulation schemes. 802.11ac employs a new scheme which is known as 256 QAM. The significance of 256 QAM is the availability of two new data rates termed as MCS 8 and MCS 9, with MCS standing for modulation and coding scheme, which achieve higher throughputs than the previously highest data rate of MCS 7, which is used in 802.11n. Because 256 QAM packs more information into a waveform, it requires more sensitive equipment to detect phases and amplitudes. And therefore, some of the constraints of 256 QAM are that 256 QAM is more sensitive to disruption by noise in the environment. This means you will need a clearer signal between the client and the access point. And in practice, you need line of sight access between the AP and the client with a maximum range of about 20 feet to get the benefits of 256 QAM. In real world settings, rate control will choose to use 256 QAM only in close proximity to the AP, maybe till around 10 meters. And as the user distances from the AP increases, the rate adaptation algorithm will automatically drop down to the next lower data rate. For example, MCS 7, which uses 64 QAM, which is what is used by 11N. So the concept of rate adaptation, for those of you, just to quickly let you know, is that if you have very high data rates, then if you don't have a very good signal strength, then it will lead to very high errors. Therefore, the rate adaptation algorithm drops the rate so that at lower rate, even if the signal quality isn't very good, you will still be able to decode the signal and get the packet. So depending on the signal quality and the number of successful and error packets, the rate adaptation algorithm automatically chooses which rate it must send the traffic at. So on comparing 64 QAM and 256 QAM, 64 QAM uses a constellation that is 8 by 8, whereas 256 QAM constellation has 16 phase shifts and 16 amplitude levels. Instead of transmitting a maximum of 6 bits on each subcarrier in the channel, a 256 QAM encoded link can transmit up to 8 bits. This single feature alone represents a 33% increase in speed over its nearest equivalent in 802.11n. Transmitting at 256 QAM requires much smaller error than the less densely packed prior constellations. The required receiver performance for 256 QAM is a gain of about 5 dB over the 64 QAM receiver performance. Now let us compare 802.11n and 802.11 AC. The first big gain we get is that 802.11 AC will support up to 256 QAM, which we have explained, while 802.11 had 20 and 40 megahertz. 802.11 AC supports up to 160 megahertz. We showed you the transmit and receive antenna settings that can be used in NetSim. 11N supports 4x4, while 11AC supports 8x8, and the maximum data rate that is supported by 11AC is about 1.3 Gbps. So with this we come to the last slide, where we talk about some of the R&D areas in Wi-Fi. These include frame aggregation for HT and VHT, high throughput and very high throughput, performance analysis of the block act scheme, and scalability analysis of different rate adaptation techniques in congested dot level networks. So we have left a little bit of time for questions, and please send us your questions through chat, and we'll be happy to answer. In case any query is not answered, we will answer your query via email. So please let us know if you have any questions. So there's a question about the propagation models that is used. See, the propagation model determines that if I have a particular transmitter power, what will be the received power at the receiver. So this is based on the channel. So for example, if you have line of sight, then you are likely to have very less losses. Whereas, for example, if you have a dense urban environment, or if you have a forest, or if you are inside a house with a number of walls, then the propagation model will need to be defined and created as per that. So in some cases, if you have very dense buildings in between, then it is likely that the received power will be quite less, which means that the signal to noise ratio will be high. So different models are available which the users can set the path loss. They can also set fading and shadowing. So multi-path fading is there. If you have multiple paths from the source to the destination, you can have multi-path fading. Else you can also have shadowing, where there is time variation. So all of this can be set. The propagation model is also open. So if users want to modify, they can then write their own propagation models and link those models to NetSim and study the performance. There is a question about 11AD. We are working on 11AD, which is at the 60 gigahertz band, and we are hopeful that we may be able to release it with the next version V10 of NetSim. As of now, we have support till 11AC. If we are using management frame along with block access. Yeah, these are some of the, so the question is, will there be any delay if we use management frame along with block act? And we believe that the answer is yes, and these are some of the areas in which there is R&D being done by researchers and device manufacturers in terms of how they can pack more information with the block act. So this may, depending on how the management frame is sent along with the block act, it may increase the delay that will be there. What format does cognitive radio use? See, cognitive radio is based on a different standard, which is 802.22, and that has to do with that if you have an incumbent, so you have primary users and secondary users in cognitive radio, and that is mainly used to utilize the available TV spectrum. So for that, the standard is different, so the packet formats and the file layer, etc. is slightly different for cognitive radio than for 802.11 AC. NetSim also supports cognitive radio simulations, and you could look through one of our earlier webinars where we had discussed the cognitive radio library in detail. And if you are using NetSim, the cognitive radio source codes are also available. And if you have any questions regarding them, you can let us know, and we'd be happy to answer them. Yeah, the throughput, there are questions about how to get the throughput graphs and so on. So NetSim comes with an inbuilt plotting utility where throughputs and delays are automatically plotted, and that is how you got some of those graphs that are shown. They are actually available if we show you on the GUI. So this option over here, dynamic metrics, if you enable this option, then it will automatically plot the graphs, and when you see the output, you will have the graphs being shown. There are also two other options that are called the packet and event trace. So NetSim is a discrete event simulator, and the packet trace logs the packet details as each packet flows through the network, and the event trace records each event which occurs in each of the devices. So both of these together is widely used by more advanced users, because they'll be able to track the flow of each packet, and they will be able to understand each event as it occurs in the network. So we'll just show you, for example, a small animation for those who want to understand. So the simulation just got completed, and some of the graphs are plotted. So here, if you go and click on view packet animation, so you can see the flow of packets from the source to destination, and the status and the time at which the flow is happening. All of this is available in runtime. So as the packets flow, you get the information that is there down. If you want to go into more detail, you can open the packet trace, you can open the event trace, and you can, based on this, you can do a little more detailed study and analysis based on this. Then what is the .11e? .11e is actually the QoS, which is the quality of service parameters are set on .11e. So for example, if you have, let's say you have three applications, voice, video, and a download, maybe a file download. So typically what happens is, voice, which is real time, will be given the highest priority, because you can't buffer, you have to have it occurring in real time. So voice is highest priority, then you have video, and then you have file transfer. So if you didn't have 11e enabled, then all three would get the same, let's say it will run on a FIFO kind of a model. So whichever comes first, that will be processed. Whereas if you have 11E enabled, then voice will be given a higher priority over video, which will in turn be given a higher priority over over data. So 11E is used for quality of service settings within WLAN. So APs that have 11E enabled will give priority for certain kinds of traffic as compared to those without 11E. Yeah, you have various, this is about the applications that are available. Various kinds of applications are available in NetSim. You can set, we will just show you, you can have CBR, you can have voice, you can have video, you can have database, you can have email, HTTP and so on. So here is a list of applications, CBR, custom, where you can write your own application, email, web browsing, HTTP, video, voice, database and so on. We also have an emulation, which is an add-on product where users can connect real devices to our simulator and send traffic through the simulator. So some information on this is available at in our website under the emulation section. Interested people can go there and then see how the emulator works. So that is one kind of application that is also available. And quickly, just to tell, for existing customers, we have a number of resources. So under support, we have a file exchange where there are project codes. We have videos where users can see videos. We have a knowledge base with various Q&A that is there. Then we have, just a second, we just show you the drop down. So we have a knowledge base. Then in resources we have some events. What are the next events that are there? So users can attend some of our events. We also have a comparison of the different versions, and we have a blog on some of the latest things that are happening. So I think thank you all for your time. This will end the webinar. Anything further, if you wish to get in touch with us, you can write to us at sales@TETCOS.com, and then your nearest channel partner is available in our list cp.html page. So you could contact the nearest channel partner, or you could write to us and we can forward it to the nearest channel partner. So thank you all very much for your time. We'll be closing this webinar now.